Welcome to Understanding Wildfire with Professor Monks. Today's topic, fire regimes. In our last video, we learned about various ways that some organisms are adapted to fire. But in reality, no organism is adapted to fire. Wait, what? No organism is adapted to fire, just any old kind of fire. Instead, organisms are adapted to certain kinds of fire. Consider a plant whose hard seeds need to be cracked open by the heat of a fire in order to sprout. Some fires may be too cold, leaving the seeds trapped in their shells. On the other hand, some fires may be too hot and just burn up the seed despite its protective shell. There's a range of temperatures that this plant is adapted to. A different plant with a thicker or thinner shell might be adapted to a different range of fire temperatures. Because of this, it's more accurate to say organisms are adapted to certain kinds of fire. We call the typical pattern of fire that occurs in a place the place's fire regime. The four most important elements defining a fire regime are type, frequency, intensity, and seasonality. When we talk about the type of fire, we're thinking about what elements of the landscape will be burned. There are three main types of fire: surface, crown, and ground. Imagine a forest with big trees, an understory of grass and shrubs, and a thick layer of dead and decomposing material like leaves and sticks on the forest floor. If a fire starts in the understory, we call that a surface fire. It burns along the surface of the land. A fire that burns up in the treetops is known as a crown fire. Most of the time, a crown fire begins as a surface fire that later spreads to the crown. Medium height fuels can help a surface fire reach the crown. We call these ladder fuels because they act like a ladder for the fire to climb up. A ground fire occurs when the dead material below the surface begins to burn. Ground fires are rare since the heat from a fire tends to go upward rather than downward, and because oxygen is limited below the surface. But once a ground fire begins, it can be very hard to put out. Frequency refers to the average amount of time from one fire to the next fire affecting that particular spot. Some places, like the savannas of Africa or northern Australia, have fire frequencies of 1 to 5 years. That is, a given spot might burn as often as every year, and will probably not go more than 5 years at a time without burning. A high-frequency fire regime tends to favor plants that can grow quickly to re-establish themselves and reach maturity in the short window between fires. Grasses, for example, tend to be dominant in high-frequency fire regimes. In fact, many grasslands around the world are maintained by fire. Without fire, often including fire deliberately set by the traditional inhabitants of the place, trees would be able to grow and take over. In contrast, some places have extremely long fire frequencies, on the range of 500 years. This is found, for example, in the boreal forests of northern Canada and Alaska. These ecosystems are still adapted to fire, and it's still part of their natural cycle, but it happens on a much more extended time scale. Intensity refers to how hot the fires that burn get. A low-intensity fire will be relatively cool for a fire. Lots of the fuel in the landscape won't be available to a low-intensity fire. It will be too big or too wet to burn when approached by a low-intensity fire. Low-intensity fire regimes often involve a lot of surface fires that never reach the crown, leaving full-grown trees untouched. These trees may be adapted to grow quickly to get out of the surface danger zone and to drop their lower branches so that they don't become ladder fuels. A high-intensity fire, on the other hand, will burn very hot, consuming everything in its path. High-intensity fires easily become crown fires. This might sound destructive and undesirable, but many species actually depend on high-intensity fires. They clear away old growth to make space for new, and some species keep their fire-activated seeds in cones high up in their branches, where a high-intensity crown fire is necessary to release them. There's often a trade-off between intensity and frequency of fire. The more time elapses between fires, the more fuel can build up, and therefore the bigger and hotter a fire can get when it finally happens. So the most common fire regimes are low intensity and high frequency, such as lodgepole pine forests in the US Southwest, or high intensity and low frequency, like Douglas fir forests in the Pacific Northwest. But the other combinations are still possible. High intensity and high frequency fire regimes can be found in the fast-growing chaparral of California or Atlantic coastal pine barrens. And low intensity and low frequency fire can be found in moist forests, where fuel is too wet to burn often, such as eastern hemlock forests. Finally, we can look at the seasonality of fire. This means, as you might expect, what season fires typically burn in. Most organisms have some sort of seasonal cycle, such as trees growing and dropping their leaves, or animals mating and laying eggs at certain times of the year. A fire can have different effects on organisms depending on when during the seasons of the year it occurs. Consider the northeastern United States, like Pennsylvania, where Professor Monks lives. Most fires in Pennsylvania occur in the early spring or late fall. During the winter, it's too cold for fires to burn well, and there's often snow on the ground. And from late spring through summer to early fall, the trees have lots of leaves, which produce shade and keep the ground nice and moist. When the fire regime of a place changes, that can create significant changes in the ecosystem, because the new fire regime may favor some organisms and harm others as compared to the previous fire regime. In many cases, the resulting changes can be harmful. For example, a policy of fire suppression practiced in the United States for most of the 20th century drastically reduced the frequency of fire in many ecosystems that had previously had a high-frequency, low-severity fire regime. This was harmful to species that depend on frequent fire. Moreover, without frequent fires to consume dead leaves, sticks, and so on, there's been a buildup of fuel. This means that when a fire does eventually break out, it will be much higher intensity, which means many species may be not well adapted to it. On the other hand, a place that already had a low-frequency, high-intensity fire regime would not have experienced this effect. Ecologists and fire managers are often interested in determining what fire regime was typical of a place in the past. In the United States, that usually means the fire regime that existed before European colonization. The idea is that if an ecosystem experienced a certain fire regime for thousands of years, then that fire regime should be sustainable. It's not a guarantee that a past fire regime is the best one for today. There may have been other changes in things like settlement patterns, land use, and climate that would interact with the fire regime. But knowing the historical regime of a place can be a useful starting point for fire management.